Now in question 11, we are told that a group of 540 people with green or blue eyes were randomly selected to determine whether the green or blue eyes are dependent of the gender. The results were tabulated below. So 11.1.1 says that if a person from this group is selected at random, write down the probability that the person is a female and has green eyes. So looking at female and green eyes, so this is green eyes and this is female, right? So we're going to look at female and we're going to look at green eyes. So where do these points intersect? At these points here, right? So the probability of a female with green eyes is 147, right? And then we have to divide by the total number of people, which is 540. So this is your solution here. So now 11.1.2 says that after analyzing the results, a learner concludes that the probability of having green eyes is independent of gender. Is she correct? So we need to prove that. So we need to look at gender, which are these two, and eyes, which are green. But you need to consider only one gender. So if you want to look at males, just look at males. If you want to look at females, just look at females. So I'm going to scratch the males. I'm going to look at the female gender to solve this problem. So you can either use the male gender or you can use the female gender. You still get the same answer. So let's look at the probability of females. The probability of female is, so the total number of females is 240, right? So it's going to be 240 divided by 540. So that is the probability of females. So what is the probability of green eyes? Probability of green eyes is, so these is green eyes, this is green eyes. The probability of the entire green eyes is actually 330. So it's 330 divided by 540, right? So now what you need to note is we are asked to compare or analyze the independence of green eyes and females. So the equation for independent events is P of females multiplied by P of green eyes must be equal to the probability of females and green eyes, right? So we just found the probability of females. So I'm just going to write it here. So it's 240 divided by 540, right? Multiplied by the probability of green eyes. We found it also to be 330 divided by 540. So now what is the probability of females and green eyes? This portion here. So we can find it in the diagram, right? So the probability of females and green eyes. If we take a look at our graph, probability of people who are female, this is females, and green eyes, it's actually this one here. So it's 147. So it's 147 divided by the total number of people, which is 540, right? So we have to see if the left hand side is equals to the right hand side. So let's see that. So having our 240 over 540 multiplied by 330 over 540 is equals to 147 over 540, right? The product of the left hand side is going to give you 0.27 and the product of the right hand side is 0.27. So therefore the events are indeed independent. So both events are independent. 11.2, we are told that E and F are independent events. P of E is equals to X, P of F is equals to Y. And P of E and F is equals to 1 over 3, P of E or F is equals to 9 over 10. So we need to show that 30y squared plus 10 is equals to 37 y. So this is how we're going to solve this problem here. So we are told that E and F are independent, right? So what this means now is, if you have the probability of E being given as X and the probability of F being given as Y, so the probability of E multiplied by the probability of F must give you the probability of E and F, right? So which means X multiplied by Y is equal to, so what is the probability of E and F? It was given. So the probability of E and F was given as 1 over 3, right? So it was equals to 1 over 3. So it means now here it's going to be equals to 1 over 3. So this can be equation 1. So maybe you can say X is equals to 1 over 3 we divide by the Y. So X is equals to 1 over 3y. So this would be your equation 1, right? So we also told that the probability of E or F is equals to 9 over 10. So let's write an equation that includes this union here. So the probability of E or F is equals to the probability of E plus the probability of F minus the probability of E and F, right? P of E or F, which is our union, was given as 9 over 10 equals to our probability of E is given as X plus our probability of F is given as Y minus our probability of E and F is given as 1 over 3. So in place of this X, we're going to put this value here that we found to be 1 over 3 y. So X is equals to 1 over 3 y. So we're going to substitute that. So we're going to have 9 over 10 is equals to 1 over 3 y plus y minus 1 over 3, right? So what we're going to do here is we're going to remove the y at the denominator. So we're going to multiply by y all sides, multiply by y, multiply by y. So we're going to have 9y over 10 equals to 1 over 3 plus y squared minus y over 3, right? So what's going to happen is we're going to multiply by 3 all sides, multiply by 3, multiply by 3, multiply by 3, multiply by 3. So you're going to have 27y over 10 equals to 1, right? Plus y squared multiplied by 3, right, minus y. So if you write it properly, 27y over 10 equals to 1 plus 3y squared minus y, right? And then we multiply by the 10. So we remove the denominator at the bottom, multiply by 10, multiply by 10, multiply by 10. So you're gonna have 27y is equals to 10 plus 30y squared minus 30y. So the common denominator, the common so we're going to have 27y is equals to 10 plus 30y squared minus 10y. So we're going to collect the like terms here. So it's going to be 27y plus 10y equals to 10 plus 30y squared. And then if you add these two here, you're going to get 37y is equals to 10 plus 30y squared. So we have proven the problem here. So 11.3, we are told that 13 learners must be seated on a bus where the seats are arranged as follows. So as you can see, this is the seating of the bus. This is the back row and this is the front row. So 11.3.1, if the learners are arranged at random, how many ways can they be seated? So we are told that the n is 13 learners, right? So if so now to identify the seating of these 13 learners at random, we're simply going to say 13 factorial, which will give you 622702080. So this would be the seating of these learners at random, 13 factorial. And then 11.3.2, if 5 friends insist on sitting in the back row, so if these 5 friends want to sit here in the back row, so the total of these friends are 5, so let's say it's 5 factorial, because they can sit on any seat as long as they fit as a 5 number. And then one learner who gets sick needs to sit next to the door. So which means this learner here wants to sit alone, so we can simply say 1 factorial. So if I write it properly, the 5 friends sit at the back row, so it's going to be 5 factorial, and this one learner is going to be 1 factorial. In how many ways can the learners be arranged? So there will be other learners that will be sitting at these other empty seats here. So these seats here, how many are these seats? There are 7. So these learners will also sit at 7 factorial. So what does that mean is all these learners will sit on each of these seats. One learner can sit on this seat, another can sit on this one, either of these seats, all these 7 seats. So to find the number of ways that these learners can be arranged, it's going to be 5 factorial, which is the learners that want to sit at the back row, multiplied by the 7 factorial, which is the learners that will sit on all these 7 seats, and multiplied by 1 factorial, which is the learner that wants to sit next to the door. So this is the solution of this problem here. So if you want to punch it in your calculator, you will get 604,800. So this is the solution of the number of ways that these learners will be arranged.